or you could say shell increases. There's more shells as you go down the periodic table.
For which one?
It's the exact opposite.
We're talking about atomic radius going down. Okay.
As you go down table, atomic radius decreases.
Increases.
No, he said decreases.
He said increases.
You said decrease, you know what it's always the opposite. If it's increasing when it's going to the
Right, let me explain it. So as you go down the periodic table, the effective nuclear charge decreases. You can say that, that's fine. And this makes the atom bigger.
Oh, so increases.
Yes, it makes the atomic radius increase. You could also say another way of explaining why this atomic radius increases is the shells increase.
What do you mean by shell?
The number of shells increase.
Are we going to have to explain ourselves, or is that
Yes,
Is
you
that
have to
enough
explain
to say
yourself.
if you can ask us that question? Because the number of
That
shells.
is enough. The next trend, are you ready for this?
Wait.
Let's do the next trend. The next trend is ionization energy. The ionization energy, you don't like ionization energy? No, I don't either. Ionization energy is the energy what? It's the energy to remove any electron. It's usually the outside. The energy required to remove an electron. That's the ionization energy. So, as you go from left to right across the periodic table, left to right, it increases.
The amount and more energy.
You need more energy
Because the atomic radius is smaller.
because the atomic radius is smaller
Can you say that?
and the Zeph is higher.
Is that enough?
That's enough to say the atomic radius increases.
Used to remove an electron or atom?
The
Can
energy,
I tell you a statement?
What is ionization? Is ionization energy used to remove an atom or electron?
electron.
So it makes it harder to isolate. No.
As you go left to right,
As you go from left to right,
ionization increases because
ionization energy increases.
ionization.
So is it decreasing?
Okay, energy
That is important.
increases because the atomic radius decreases.
Yes. Now, you can now talk about the trend from top to bottom on the periodic table, from top to bottom. Ionization energy decreases.
Because it's easier to steal.
It's easier to steal, but why is it easier to steal?
Because the atomic radius.
The atomic radius is larger. The electron is farther away. There is less effective nuclear charge. So all of these reasons are the same, really. They all kind of boil down to the same thing. Really, effective nuclear charge is at the bottom of it all.
So ionization energy decreases because of that.
Yes.
And sorry, last
Watch the video.
thing.
Okay. Electron affinity. Electron affinity. Electron affinity now is something different. What is electron affinity? It is the atom's ability to attract electrons. So it's the Brad Pittness. Yeah.
Electron affinity. Atoms ability.
You can write this when you get home.
Attract electrons.
Very good. Now, think about how this is so closely related now to effective nuclear charge. It's like the same idea, really, right? Because if effective nuclear charge goes up, that's really what you're saying is that the nucleus is really attracting its own electrons. So it'll also attract passing by electrons, too. So that means that if effective nuclear charge goes up, then it's also going to increase its electron affinity,
Yeah, word.
right? Because it's gonna attract any passing by electron
True.
more than if it had really low effective nuclear charge. Yeah.
So when it's going across, it's increasing.
So when you're going across the periodic table from, let me see if I get this right, from left to right, you're increasing the effective nuclear charge and you're increasing the electron affinity because
you have a stronger, more effective nuclear charge, you're more able to attract the electron.
Yeah.
Okay.
And now implement the later.
And right. Now the last little piece, the last piece of the puzzle. I know you're ready for this. As you go down the periodic table, the electron affinity now Is that increase or decrease? Guess.
Decrease.
It
Is increase.
decrease.
I don't know, you just made the face like maybe we were wrong, so I just decided to say
I don't know. Decrease. It decreases. Why does it decrease?
The Zeph is lower,
Yes.
and there's like less attraction between the nucleus and the.
Yes. It's a less attractive
Always
nucleus.
the opposite, right?
It's totally an ugly Brad Pitt with the dreadlocks and everything.
Why is the nucleus less attractive?
Because the Zeph is lower.
There's more shells that are shielding that nucleus.
It's not as
So we-
attractive.
Oh, so shells are made to protect the nucleus.
They're protecting it. Hey!
I
Yep.
get it. It's all like a I don't know, it's just like clicking.
It's clicking. That's great.
Wait, I have an
But
idea.
it's better late than never.
What if
Yeah.
I just write like electron affinity and then like an arrow which way and then like decrease or increase? That'd be easy.
That would be easy. Yeah.
So
I think you just need to relax for a bit. You do know this stuff.
Let's do Mendeleev and then.
Review it tonight. It'll be fine. Let's talk about Mendeleev, and then we'll be done. And I'll talk to you guys off camera about reactivity. Off camera.
confidential stuff.
Mendeleev is important for really just a few reasons. He was not the first person to make a periodic table. Shocking. But he was the first person to make a periodic table that had what?
That had like gaps to leave.
Patterns, and it had gaps, spaces for new elements to be discovered.
Wait, first person.
You have to know the shuffling cards on the train.
Table.
No, but you know it right now because you just told me that, so that's great. I love that question. Do we need to know about blah, 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 blah? Well, you just said it, so you know it. Why are you worried about it?
For new elements. Forget it.
Yes, Mendeleev. He was. What else was he famous for? He's famous for not being a very tidy dresser, attractive guy. Yeah. Oh, that's like the un-Brad Pitt. So they range from Mendeleev to Brad Pitt.
Like space for new elements.
There we go.
Wait, didn't he know that like elements were going to be discovered later on?
He knew that they would be discovered. He didn't. Well, that's hard to say. He knew. I would say he predicted that they would be because they seemed as if they needed to be there, since there were like gaps in the
Did
table.
he make like these like cards?
He made the cards. He shuffled the decks, and he made the little trends out of those decks. And he found out, oh, they seem to be in the table.
And he was crazy looking.
You should make.
That's what we just said.
Chelsea
Unkempt. There we go. Unkempt. So unkempt.
Chelsea Renee.
I bet we the best.
Maybe. Okay. All right. That's it.
React
Happy studying.